this problem number 8, because it mentions the word burning, it says C2H6 burns, that tells me I need to write a reaction. Anytime I can write a reaction, and then I can use this heat of formation sheet to calculate a heat of reaction. So before I go any further, just because of those words, write my reaction. Burning is adding O2, making CO2 and water. Making a note to myself that the water that's produced anytime I burn something is going to be a gas. You've never seen water drip out of a flame, so we assume it's a gas. Balancing my C's, then my H's, then my O's. There were 4 plus 3, 7 oxygens here, so at 7 halves there, we'll do it. Calculating my heat of reaction. Products, so 2 times the value of CO2. Looking on my chart, negative 393.5, plus 3 times the value for gaseous water, negative 241.8. Products minus my reactants, C2H6 plus 7 halves times O2, but O2 is a pure element, so it's going to have a value of 0. I don't need to include it. Simplifying this, 2 times negative 393.5 plus 3 times negative 241.8. I get negative 1512.4 minus negative 84.7. Switching markers. Negative 1512.4 minus negative 84.7. I get a heat of reaction. I get negative 1427.7 kilojoules per mole. Once I have a heat of reaction, I can go into some kind of proportion. The proportion is always about the reaction. I can relate it to water later if the question asks about it. This question doesn't ask about it. So the only piece I still have to incorporate are the 8 grams. The 1427 kilojoules, I know are going to be released, so I can already answer that part of the question because the heat of reaction was negative. I dropped the negative moving forward because it told me all I needed to, that the heat's released. That heat is for 1 mole of C2H6. The mole means the same thing as the coefficient, so I used the coefficient of C2H6. The reason I used that coefficient rather than any of these other coefficients is because the only other piece of information I have is also about C2H6. So on the other side of my proportion, I need these to match and be literally about the same thing. So this also needs to be moles of C2H6. That will let me solve for the heat, kilojoules released. Turning the 8 grams into moles, molecular weight 12 times 2 is 24, plus 6 is 30. 8 divided by 30 gets me 0.27 moles. I kept this number in my calculator and just multiplied by 1427.7. Cross multiplied, I get X is 380.72 kilojoules, and they'll be released because the heat of reaction was negative.